So I think in general, the industry is very accepting and understanding that there is significant benefit in applying AI to the wealth of data that comes out of the cheese make process. And that by doing that, there's the opportunity to improve the process, reduce variations, and then generate value. I think the communication of that to the industry really comes down to helping a company to understand what are the critical steps in their process that drive the variability, and then giving them some concrete examples of how that can be reduced.
Well, the first thing I would say about communicating yield optimization is that it's really about eliminating process variation versus just focusing in on the financial results. The results come about, the dollars or euros come about as a result of the process improvement versus just focusing in on that. If we can get the process to be more standardized, we can, as a plant, we can maintain and move whichever way we need to go, because sometimes the answer is it's more for quality versus maybe it's for moisture. It all depends on what the individual company needs to achieve.
So I would say that the dairy industry, traditionally, historically, had been maybe a little bit behind from a technology adoption point of view to where some other industries have been. But over the last couple of years, data science, artificial intelligence, supply chain enablement software is really starting to pick up in the dairy industry.
Well, I would just say that the value of the fat in the cheese has changed the story. So if you are in certain types, if you're making cheese where the answer is, I can sell that fat for sweet cream instead of putting it in the cheese and I can make more money, the answer's been, I change my formulation to have less fat on a dry basis in the cheese. So that is a very different dynamic of the problem solving around yield optimization versus traditional, just get as much cheese at all costs because I can sell it that way. So I would say it's an economic reality that is unique to each type of product mix and each type of business model that is being sold out there today.
In some of the implementations we've gone through and some of the case studies, we've seen marked reduction in the standard deviation, which again, that represents how much variability there is in the process. And by reducing the variability, we're then able to more accurately target the edges of the quality measures without the risk of generating undergrade. And by doing that, we've shown you can increase the overall yield by several tenths of a percent.
So what we have seen is that it's different by every plant. Sometimes the plant is about cultures and being able to, like if you're doing bulk starter sets, of being able to take into account the fact that each starter is a little different in how it behaves and how you have to take into account the phage that gets created, etc. That's one side. And then the other side of it is that other plants are all about the salt or the amount of water that is being sprayed on it. You have to, the model has to be smart enough to be able to adapt to each individual plant to achieve that reduction in standard deviation is the way I would describe it.
I think as Ryan had mentioned, as we went into this, we thought giving daily recommendations would be sufficient here, but really we found that there are specific points in a cheese make process where you have data on what's been happening and you have the ability then to alter subsequent steps. So you could change the amount of curd wash you're doing, change some set temperature points, for example, later in the process. And what this has meant is we need real-time integration into the plant floor systems and be able to turn around and give back actionable guidance on what to change within a day. That wasn't necessarily something we had assumed we were going to be doing as we got into this.
Well, I would describe a couple of the challenges have been, like one of the customers is making Kojak, and the answer is those are paired vats where, for example, vat 1 and vat 2 are being put together to create Kojak. Being able to tell the model to learn VAT A and VAT B separately, and then to see the combined impact of it was a challenge that we hadn't envisioned when we were a year ago. And then some other things are just really about plant individual specifics, about instrumentation variations that need to be accounted for in the model are probably the two biggest things that I would say we've honed in on.
So it is a little different at each facility we look at, but I would say some of the obvious factors would be the milk that's going into the make process. What is the protein to fat ratio? That can have a significant difference, obviously, in the yield, and also as markets change, that has a different cost impact. And then within the process itself, there are certain set temperatures, amount or timing of curd wash, belt speeds, amount of salt that's added. There are a couple of critical points here which can be changed up or down on any given vat. And we see that in different plants, different factors drive more variability.
Well, it's always been true in dairy that the protein to fat ratios have always been the number one things that drove yield. That is all still true. The number two things have always been the cultures, the starters that are in the vat that are out there. The things that I would say that we have learned that can be different have been curd wash time, curd wash temp, the stir speeds. It can even get some specifics into the temperature in the plant. Like we have seen where by hooking up into the HCV temperatures, it can play with the humidity and some of the moistures and drive process variations. So sometimes it's the things you think about in the vat, but it's also the things outside that are a little different. So I would say we've learned several important factors along the way beyond what we thought were the obvious ones.
So the Van Slyke model, really, it's been in place for 100 years, and it gives a good view of what the expected yield will be based on the fat and protein content of the milk coming in. And as we got into this, we were maybe a little surprised by the lack of consistency and accuracy of that model. And so really with the yield optimization, we're now able to make predictions of what the yield will be based on, yes, the fat and protein content of the incoming milk, but also the settings of the machinery along the process to come up with a more accurate model.
Well, what I would say is generally when we have gone out in the past year and talked to people, Van Slyke is always a reference point, but it's never been the gospel, but it was always, I take this and I do this with it to modify it to represent my plant. What we have found is that each plant and each model and some of the recipes need their own variation of it. Again, going back to that Kojak example of the pairing of the two vats, that changed the model versus if you were trying to do that with the Van Slyke, you really have two different types of cheeses you were trying to optimize and blend them together. You have to be specific to those two types is kind of what we've gotten out of it, for example. But to each plant, it is slightly different.
So, in general, there has been the need to walk alongside the cheesemaker, understand what they're doing in their plant, be inquisitive, understand their process. And, in doing that, I think we do a good job of getting the buy-in from the cheesemakers to really see the value of this process. So, one of the easiest ways is to take some historical data, take one formula, model a year's history, come back with some recommendations on what we see as the most relevant factors, and then go through and do some kind of backcasting, where you say, if these things had been done differently, how much benefit is there? And then we can get people excited because we can show, it's a third, half a percentage point increase in yield, and a reduction in undergrade is possible through this process. And when people see that amount of potential benefits available, it tends to get people excited. That real-time integration I was talking about, being able to, at different points along the process, have the model run, come up with recommendations, they get fed automatically into the MES system. So I think over the coming years, that process will just become more and more automated and easier for the cheesemakers to use. It's still going to be critical to have a person who really understands the process running the system. But the ability to train a new person, to have the one person use the same, one company have the same process at every plant, rather than different cheesemakers making the same item for the same company at different plants and having different outcomes.
So when we were here last year at this time, I would say it was more of an introduction, and it was more, people didn't necessarily believe in it, they were intrigued by it. But I would say at this point, it's more of they believe in it, they're interested in tackling it, they're more into what are the ramifications to my specific plant and how that can be. And an example of that is that a couple of weeks ago I was visiting a customer, and they were very specific to say, the cheese technologist was, I don't want this to just juice the bottom line, I want it to make good product. And so being able to understand what the business objective is almost as important as just getting anywhere. So I would say that is where we are at now, is that it's not people believe in the technology, it's how it's used now is where we're discussing more these days. Well, I don't know that the standards of making good cheese have changed at all, but I would say it has really focused in the discussion around that process improvement that we were talking about just a bit ago, of being able to, I like to use the analogy, there's a standard deviation around how product is made, and if I can get it to this, the answer is I can move my targets around to achieve whatever directives I really want to achieve with it. And sometimes the answer is I want less fat in the milk, right, or in the cheese, because I can sell it for sweet cream and make more money doing that. Whereas in different market conditions, the answer is I want more moisture and I want more protein in there. So it depends on economic environment, plants' economic goals, as well as sometimes what their tolerance is for undergrade, because some plants can afford it around a certain type of cheese because it's financially available there, and others you can't, because you can't sell the cheese if it's off spec. Well, some of the biggest surprises to date have been really focused in around probably focusing in around humidity around the plant, being able to keep their HCV environment consistent. The other thing that has shown up is that there's a little bit of what happened with this vat, of it's out of tolerance, it wasn't what we expected, and understanding why all of a sudden you get these outliers. And what we have found is that by getting tighter feedback around the production cycle and capturing that data, you find the one-off things like an operator accidentally left a panel open, or they didn't follow the proper process. Being able to isolate those things have probably been the biggest drivers. So again, it always comes back to the process standard deviation, is that at the end of the day, the financial results always come back to whether or not I can have my process more well-defined, more in control. And again, it always has come back to identifying those outliers and being able to eliminate those to get more science applied to the art of making cheese has probably been the best distinction there. And again, it would come back to sometimes it's been the examples around cultures, it's been examples around the environment, it's been examples around process itself. So it's been a couple different things depending on what each plant has been trying to achieve. Well, one of the things that we have learned in the last year is that advancing cheese yield originally was thought to just be about being able to have the machine learning come back and make a daily recommendation to say, hey, if this is what I want to make tomorrow, here's how you should make it. That's step one. Step two is about those, I call it real-time process changes that need to be made. The example I would give is we have one where the protein to fat ratio is out there, so it changes the curd wash in real time. You can't do that on a daily basis. You have to do it in real time when the vat is being filled. So that would be the second thing. And then the third thing that has really come about at the plants has been what I would call replacing the tribal knowledge, that so many of these plants have people that have been there for 20, 30 years, and they just know that when this happens, that what we have discovered is that we need to, if you really want to take it to the next step, you have to do what I call if this, then that. And that if this, then that is what's tribal knowledge in these people's heads. And by getting that into the software so that the answer is when the next generation comes along, they don't have to learn the hard way. All that if this, then that is in the software so that the learning curve, instead of it being 3 years, might be 40 days, for example. So the number one thing I would say that we have found is that there does tend to be some fear, but when you really get into it and they understand what the process is, that it's not replacing that knowledge, it's really optimizing it and leveraging what they've already known so that they can focus in on those things that are needle movers, like process changes and those pieces. It's really helped to break through things. There's been a couple challenges along the way where people have been hesitant about it. But I've generally found that if you just sit down and talk to them and you explain the key about that process improving it and getting that standard deviation reduced, that's what everybody wants to achieve. And then from there, the rest of it's just business. What's the right thing for my business? What's the right thing for my plant? What's the right thing for my customer? Everybody has an economic success factor that they want to achieve, but ultimately when we get into these discussions, and sometimes it'll be 10 to 15 minutes, it always comes back to what I call the standard deviation around the process. As long as that deviation is reduced, that is a success to them because they then know they can change their economic model faster to the realities that exist in the industry so that they can be nimble and achieve whatever financial results they need to move forward.